Hello students, we were doing vector algebra. Today we are going to start questions related to collinearity. Let us start with the questions. Question number 1. Write down the statement. If A vector and B vector are non-collinear vectors such that x1 A vector plus y1 B vector is equals to x2 A vector plus y2 B vector, then prove that to prove x1 is equals to x2 and y1 is equals to y2. Now we have given that this is equals to this. We can write it as x1 minus x2 A vector plus y1 minus y2 B vector. Now we have given that A vector and B vector are non-collinear. Therefore, x1 minus x2 0, yeah, y1 minus y2, that would be equal to 0. So x1 is equals to x2 and y1 is equals to y2. Here the reason is because A and B are non-collinear. Now the next one. If A vector and B vector are non-collinear vectors, find the value of x for which vectors alpha is equals to x minus 2A vector plus B vector and vector beta 3 plus 2x A vector minus 2B vector are collinear. Now we have to find the value of x here when alpha and beta are collinear vectors. If alpha and beta are collinear, then alpha vector is equals to lambda into B vector, where lambda is any scalar. Put the value alpha x minus 2 A vector plus B vector is equals to lambda into 3 plus 2x A vector minus 2 B vector. Now A vector on one side, x minus 2 minus 3 lambda minus 2 lambda x plus B vector into 1 minus, when it goes on left hand side it becomes plus 2 lambda is equals to 0. Now since A and B vector are non-collinear vectors, therefore x minus 2 minus 3 lambda minus 2 lambda x is 0 or 1 plus 2 lambda is equals to 0. From here lambda is equals to minus 1 by 2. Put this value of lambda here. X minus 2 minus minus plus 3 by 2 minus 2 into minus half x minus minus plus x 2x. Take the LCM, minus 4 plus 3 minus 1 by 2. 2x minus 1 by 2 is equals to 0, or we can say that 2x is equals to 1 by 2. 2x is equals to 1 by 2. Not up to here. And x is 1 by 4. Note it down. Now next one. Next is, if A vector and B vector are non-collinear vectors, find the value of x for which the vectors alpha is equals to 2x plus 1 a cap, A vector minus B vector, and beta is equals to x minus 2a vector plus B vector are collinear vectors. A and B are non-collinear, but alpha and beta are collinear vectors. Therefore, alpha is equals to lambda into beta vector, where lambda is any scalar. Now put the value of alpha 2x plus 1a vector minus b vector, lambda into x minus 2a vector plus b vector. Now it becomes 2x plus 1 minus lambda x minus plus 2 lambda. Minus 2 lambda, when it goes on left hand side, sign will change, plus 2 lambda a vector minus b vector 1 plus lambda. Now A vector and B vector are non-collinear vectors, therefore this is equals to 0, or lambda plus 1 is equals to 0. From here we get lambda as minus 1, put the value of lambda, minus plus minus 1. 3x minus 1 is 0, so we get x as 1 by 3. Now next one. If A vector, B vector, C vector are three non-null vectors. Null vectors means 0. Non-null vectors means A, B और C vectors की value 0 नहीं है. Such that any two of them are non-collinear. If A vector plus B vector is collinear with C vector, and B vector plus C vector is collinear with A vector, find A vector plus B vector plus C vector. We have given that A, B and C are non-null vectors and A plus B is collinear with C. So let it be lambda 1C, lambda is any scalar. B plus C vector is collinear with A vector, let it be equals to lambda 2A vector. Lambda 2 is any scalar. From here find the value of A vector, that is lambda 1 C vector minus B vector. Let this equation as 1 and this as 2. Now put the value of A in equation 2. B vector plus C vector lambda 2. Lambda 1 C vector minus B vector. So it becomes B vector plus C vector. B vector is equals to 1 plus lambda 2 plus C vector 1 minus lambda 1 lambda 2 is 0. A, B और C are non-null vectors, means A, B या C vector की value 0 नहीं है. Therefore 1 plus lambda 2 is 0, that is lambda 2 has value minus 1. 1 minus lambda 1 lambda 2 0. Put the value of lambda 2 minus 1, so minus plus 1. So lambda 1 has value minus 1. Put the value of lambda 1 minus 1 in equation 3. Put the value of lambda 1. A vector is equals to minus C vector minus B vector, or we can say that A vector plus B vector plus C vector is equals to 0. A vector plus B plus C vector is equals to 0 vector. Now the next one. Let A, B, C is collinear with C vector and B vector plus 3C vector is collinear with A vector, then prove that A vector plus 2B vector plus 6C vector is equals to 0 vector. Now since A plus 2B is collinear with vector C, so let it be equals to lambda 1C. B plus 3C is collinear with A, so lambda A2. Lambda 1 and lambda 2 are scalars. Let this equation as 1 and this as 2. From equation 1, find the value of vector A, lambda 1C minus 2B vector. Put this value of A in equation 2, B vector plus 3C vector lambda 2, lambda 1C minus 2B. Now B vector into 1 plus 2 lambda 2 plus C vector 3 minus lambda 1 lambda 2 is equals to 0. Now A, B and C are non-zero vectors. Therefore, either 1 plus 2 lambda 2 0 or this is equals to 0. From here, find the value of lambda 2 is minus 1 by 2. Put the value of lambda 2 here, 1 by 2 lambda 1 0, 6 plus lambda 1 0. So we get the value of lambda 1 as minus 6. Now put this value in equation 3. Put this value of lambda 1 in equation 3. So we get A1 is equals to minus 6C vector minus 2B vector. That is A vector plus 2B vector plus 6C vector is equals to 0 vector. Now next one. If A vector, B vector are non-collinear vector and the vectors alpha x plus 4y A vector plus 2x plus y plus 1 B vector and beta vector minus 2x plus y plus 2 A vector plus 2x minus 3y minus 1 B vector are connected by the relation 3 alpha vector is equals to 2 beta vector, find the value of x and y. 3 times alpha vector, 3x, 4 into 3, 12y, 3 into 2, 3y plus 3 b vector is equals to 2 times beta vector minus 2 into 2 plus 2y, 2 into 2, 4, 2 into 2, 2 into 3 and 2b vector. Now A vector is A vector into 3x plus 12y. When this term goes on left hand side, sign will change, plus 4x minus 2y minus 4 plus b vector into 6x plus 3y plus 3 minus 4x plus 6y plus 2 is equals to 0. Now A vector 7x plus 10y minus 4 plus b vector into 6 minus 4x 2x 3 plus 6 9y plus 5 is equals to 0. Now A vector and b vector are non-collinear vector. Therefore 7x plus 10y minus 4 is equals to 0 or 2x plus 9y plus 5 is equals to 0. Now we have to solve these equations. We will solve this by using the elimination method. Make the coefficient of x equal. We have multiplied this by 7 and this equation by 2. 7 into 2, 2 into 10, 2 into 4. 2 into 7, 9 into 7, 7 into 5. Now subtract, x will get cancelled. So what we have left with 43y minus 43. Minus 43y is equals to 43. So we get the value of y as minus 1. Put this value of y in any one of these equations. 2x, 9 into minus 1, minus 9 plus 5. Minus 9 plus 5 minus 4. 2x is equals to 4. So we get the value of x as 2 and y as minus 1. Now next one is, let u vector is equals to I cap plus 2j cap, v vector is equals to minus 2i plus j, and w vector is equals to 4i plus 3j. Find scalars x and y such that w vector is equals to x u vector plus y v vector. Now we want to find the value of scalars x and y when this is the relation which is given. W vector 4i plus 3j, xu xi plus 2xj, v vector multiplied by y minus 2y I cap plus y j cap, x minus 2y I cap plus 2x plus y j cap. Equate the equal components, same components. X minus 2y is 4 and 2x plus y is 3. Multiply this equation by 2 to make the coefficient of x equal in both equations. 2x and this is 2x plus y is equals to 3. Now subtract the equations. Minus 5y, 8 minus 3 is 5. So we get the value of y as minus 1. Put the value of y in any of these two equations. X minus 2y is equals to 4, minus minus plus. So 4 minus 2 is 2. Now the next one is, show that the points with position vectors a vector minus 2b plus 3c minus 2a vector plus 3b vector minus c vector and 4a vector minus 7b plus 7c vector are collinears. Let PQR be the points with position vectors this, and this. Now first find PQ vector, that is position vector of Q minus position vector of P. Minus 2a plus 3b minus c minus position vector of A, change the sign, plus 2b minus 3c. So what we get? Minus 2a minus a plus 3 plus 2 minus c minus 3c. P, Q. Now find the value of QR. QR is equals to position vector of R minus position vector of Q. Position vector of R, 4a minus 7b plus 7c minus minus plus 2a minus 3b plus c. 4 plus 2, 6a minus 10b plus 8c. Take negative 2 common from here. Minus 3a plus 5b minus 4c. So this is equals to minus 2 times PQ vector. Therefore, PQ vector and QR vector are parallel vectors. but Q is the common point. Therefore, P, Q, R are collinear. Next one, show that the points with the position vector A vector minus 2B plus 3C minus 2A plus 3B plus 2C minus 8A plus 13B are collinear whatever the value of A, B and C. Let PQR be the points with position vectors this, this and this. Now find PQ vector. Position vector of Q minus position vector of P, subtract minus 2 minus 1 plus 3 plus 2 plus 2 minus 3. Now QR vector, position vector of